15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again, and thank you for joining us on this, the 204th edition of the Space Nuts podcast. It's great to have your company yet again. And joining me, as always, is Professor Fred Watson, Astronomer-at-Large. Hello, Fred.
G'day, mate. How was that?
That was pretty ordinary.
Yeah. I can't do it. It's terrible.
No, it's not something that a non-native can really handle.
That's right.
You can always pick a fake.
Yeah.
But, please don't do it again.
No,
now, today we've got a couple of launch stories to talk about involving SpaceX and Virgin. One that may or may not happen and may or may not have happened by the time people have heard the podcast, and the other that did happen and then it didn't. So we'll talk about that. A new planet formation has been discovered by the BLT Sandwich Telescope, or the VLT as we call it, the Very Large Telescope. And we've got a couple of questions, one about redshift, and we've got an audio question from Giuliano in Wellington, New Zealand, which we'll get stuck into soon. I like his question because it does bring up some philosophical concepts in terms of intellectual or extraterrestrial intelligence finding us. And we have talked about that before in terms of how would the world react if they discovered tomorrow that there's extraterrestrial life, intelligent life, but what if they found us first? Is what we're going to be talking about today. So we're going to tackle all of those questions and situations on Space Nuts. So let's start off with SpaceX, Fred. They are basically gearing up for a launch this week, which may or may not have happened by the time people are listening to this podcast. And I think the problem they're facing at the moment is weather.
That's exactly right, Andrews. We kind of hope, I guess both you and I are hoping that this is all redundant information by the time the podcast reaches the earphones of...
Well, that's one of the two pillars of our reason for being, adequacy and redundancy.
Yeah, exactly.
If we can achieve both of those things, we've done well.
Well, yeah, we're both pretty redundant anyway, but that's all right. It's a story well worth covering. From where we sit at the moment, less than 24 hours before the launch, it's very exciting. We have the first crewed mission from the United States since the space shuttle, and it's two US astronauts, Bob Behnken and Doug Hurley, and a US-built spacecraft. The SpaceX Falcon 9 is the launch vehicle, and their Crew Dragon is the capsule that will carry these two astronauts into orbit. And of course, it will be launched from Pad 39A at Cape Canaveral, where the Saturn V's and the shuttles left from. So a big moment, really, in space history, and I am very excited about it. I think many people are. It's not just about national pride, the fact that American astronauts have had to use the Soyuz shuttle service, Soyuz spacecraft, for the last 9 years to get up and down to the space station. That, of course, is something that they're quite keen to move away from, just to give more flexibility as well as anything else. But it's also cheaper. SpaceX can do it cheaper than Roscosmos can do by quite a significant margin. It's not a cheap trip to orbit, Andrew. Have you got any ideas how much it costs?
Well, I can only go to actually do the whole deal and get one into space.
Yeah, all right. Let's put it a little bit more, specifically. The cost per seat for an astronaut.
I would have thought a civilian astronaut that they were talking about in the tourism sector was somewhere around the $250,000 mark. but I imagine it'd be more for a SpaceX launch.
Yeah, that's right. Actually, that's really interesting you should say that, because the cheapest of those tourists, this was again Soyuz, back in the early 2000s when Space Adventures brokered a deal between rich people and the Roscosmos. The minimum charge then was $20 million US.
Yeah, that's right, I remember.
And that gave you a few days in the space station as well. I think one of the customers probably paid twice that much, which is quite remarkable. But the cost that NASA is being charged for astronauts being ferried up and down to the space station is $85 million per seat.
Whoa.
So it's expensive. And SpaceX promises to bring that down significantly with, I think they're talking about $55 million each for the two astronauts that are flying today. But this spacecraft can hold a total of 7 astronauts. There are only 2 on board. So if you fill it up, it comes down significantly further. I've heard a figure of 20 million per seat.
Well, it's only 2 because of social distancing requirements of COVID-19.
Yeah, I think it was always going to be
what's happening there.
Always going to be 2 for the first test. It's actually, even though it's the first flight, it's called Demo 2 because Demo 1 was the same thing, but doing it all automatically with no astronauts on board, and that was a success last year.
Yeah, having been to Cape Canaveral, and you mentioned Launch Complex 39A, you don't really get a sense of scale when you're watching a launch on television because everything's focused on the rocket or the space vehicle or whatever, and the countdown clock. But it is a massive complex. I mean, you look out over the vastness of it, and you can see the different launch pads dotted all over the place. It is really quite a remarkable facility. I really enjoyed my day there. I had a great time. Fantastic.
So,
just saying.
Yeah, no, you're just saying because I haven't been there, but I will one day.
Well, there's not many places I've been of an astronomical nature that you haven't, Fred. So I've got to flaunt it when I can.
Yeah, you go for it, Andrew. I don't mind that. I hope to get there someday because it will be a wonderful place to visit. So going back to the other space story, we kind of leave that one because it's sort of hanging in the air, is the Virgin Orbit mission to make their first attempt at launching into orbit or launching a spacecraft into orbit from an aircraft. You have been reading about that, I think, as well.
Yes, I have. This was a launch that I think was going very, very well, and in fact, they did release the launch vehicle from the belly of the 747 Jumbo, but then they had to terminate. Something went wrong that they referred to as an anomaly.
Anomaly, that's right. And we don't yet know what that was, but you're absolutely right. And this in itself is pretty exciting because Virgin Orbit are positioning themselves in the launch market for small spacecraft. Their rocket, which the example that was used the other day was called Launcher 1. They tell it like it is.
Yeah, they do. It's Astronomy 1. Yeah. Astronomy 101. Your very first class when you go to university to study astronomy is, this is how we name things. Keep it simple.
Keep it simple. So Launcher 1... and the class of spacecraft that it is can carry up to about 500 kilograms into orbit. That's half a ton, effectively. And the idea is that you ferry it up to about 10 kilometers or about 6.5 miles altitude under the wing, actually, of the 747. Something I didn't know is that 747s, and I think this might be standard across the whole range, have a spare pylon underneath the wing, which was meant to be able to carry a spare engine.
I believe, I did know that, actually, yeah.
And so they've modified that to carry the rocket. And the idea is you fly up in the jet up to this height, and then the rocket's released. It's I think the jet tilts upwards to release the rocket. The rocket then fires its motor and away it goes up to a much higher altitude, and of course with the horizontal velocity it needs to get into orbit. So everything went brilliantly, apparently, except and including the initiation of the burn. They pressed the button and the rocket fired, but as you said, some anomaly shut it down. We'll hear, I'm sure, about what happened. Virgin, the kind of Virgin group of companies overall, and they're not actually connected except in any other way than the name. But certainly Virgin Galactic, Richard Branson's other pet occupation, they've been incredibly tenacious with keeping going when things have not looked as though they're working all that well. They've got over huge numbers of hurdles, and I suspect that same ethos probably permeates Virgin Orbit, even though the two are actually not connected. Virgin Orbit will, I'm sure, be working on other missions, and they want to do it soon because they clearly want to start trading and get into business.
Absolutely.
Yeah. So I'm hoping you'll...
And Launcher 1 was quite a big rocket. It's over 21 metres in length, which is pretty significant.
Yeah. I'm hoping you'll ask me why they do it this way, Andrew.
Why they drop them from the belly of a plane?
Yeah, rather than setting them up on on launch pad 39 and lighting the fuse down there.
I would hazard a guess that it gives them some velocity to work with, a sort of a bit of a speed advantage rather than, and saves fuel.
Yeah,
that's just a guess.
It's that's probably true, but I think they're fairly marginal advantages. And the height, 10 kilometres, you've got to get up to probably more like 200 kilometres for a stable orbit. So you're not really giving it a height advantage. Apparently, what really underpins this business model to do this is the flexibility. And in many ways, we've got the perfect example because we've just been talking about the possibility of weather stopping the launch of the SpaceX, crew, or it's a crew in the SpaceX rocket. If you are flying your rocket aboard an aircraft, you can actually pick where you want to launch from, and you can pretty well go anywhere in the world with a choice of the best weather conditions, and also you can place yourself so that you're optimally positioned for the orbit that this thing, whatever it is designed to go into. You can actually, you've got an advantage in being able to put it in the right position to get the right orbit. So it's quite a complex reasoning behind it. But Virgin Orbit are, I think, very gung ho about it. I think they think this is a winner in the small satellite launch arena.
Yeah, I'm sure they'll iron out the anomaly and learn from that, and they'll work forward from there, and they will have success. I have no doubt about that. And I do want to sort of just mention the 747 Jumbo. What a great workhorse of an aeroplane that has been over many, many years, and so versatile to be able to do everything from run cargo and passengers to be able to do launch vehicles like this. I think it's the best plane ever made in history, I would suggest.
You're probably not far off the mark there. I think that's right. And, an extraordinary, as you say, extraordinary workhorse. You and I
I've only ever been on one in my life, believe it or not.
Seriously?
One.
I thought you were going to you'd been on dozens.
No, I've been on the A380 about 5 or 6 times, but only one 747.
Okay, well...
So, and the way things are, probably the only one I'll have ever been on too.
Yeah, no, I've spent a lot of my life in 747s, as you can probably imagine, going between Australia and Europe. And, always reliable. I have to say the A380 is quite a lot quieter, but that's, what's that? That's not that much of a difference.
I love the A380, but sadly both planes coming to the end of their working lives because there are smaller, cheaper, faster, more efficient planes on the market now. So the whole aviation game was set to change, and then COVID-19 came along and changed it for them anyway. But the future will be very different in aviation. We'll miss the 747, I can tell you that.
Yep.
This is Space Nuts with Andrew Dunkley and, of course, Fred Watson.
3, 2, 1.
Space Nuts.
Now, I've mentioned being able to become a supporter of our podcast through, a couple of platforms now, Patreon, of course, and there's another one called Supercast, and you can find all the details on our website at bitez.com, bitez.com. Now, one of the other things that we're offering is premium membership. Now, you can become a premium member of Bytes Network, and you can choose your own bundle. So, for example, for $7 a month with a 28-day free trial, you can combine Space Nuts and Space Time with Stuart Gary. For $8 a month, you can combine Space Nuts, Dark Sky Conversations, and Space Time. So check it all out at Bytes Network. That's BITESZ network.supercast.tech, bytesnetwork.supercast.tech. You'll find that on our website if you want to have a look at it. It's optional, but there are benefits to becoming a premium member of the Bytes Network. Now, Fred, let's talk about this planet formation that's been spotted by the Very Large Telescope, and it's only 520 light years away. I just saw the bus out the front stop to pick people up to go there.
On our doorstep. Actually, for planetary work, it's quite a reasonable distance. Is that 520 light years? It's it's a star in the constellation of Auriga, which is the Charioteer, a northern constellation. It's named AB Aurigi, and the AB tells you that it's actually a variable star. That's the two letters like that are always variable stars, ones that vary in brightness. But it's been of interest to astronomers for quite some time. There is a team of astronomers based, actually it's a fairly global group, France, Taiwan, the US, Belgium. These are scientists who are particularly interested in the star, but also the fact that it has what we call a protoplanetary disk around it, a disk of material, which is where planets are forming. Now, you and I have spoken before about these things, and the world's best telescope at seeing them is ALMA, the Atacama Large Millimeter Array in northern Chile. ESO is also a partner in that, but the US and other countries are too. ALMA is a telescope that looks essentially at the microwaves, if you like, coming from space, and it turns out that the energies that these dusty disks radiate at are detectable by ALMA, and they've been great at finding disks of dust around young stars where planets are being born. But what's now happened is that after observing AB Aurigi with ALMA a few years ago, this same group have actually used a new instrument on the Very Large Telescope down there, not very far from ALMA, a bit further south, down in Chile, in the mountains, in order to probe it even more. And this new instrument, it's actually called SPHERE. I can't remember what SPHERE stands for. I know the P is polarimetry, and that tells you something interesting about it, that it looks, it's sensitive to the polarization of light. And that's very important when you're looking at a dust cloud, because dust actually does that. It polarizes the light. I guess most of our listeners will be familiar with polarized light from the use of polarizing sunglasses. They let the vibrations in one direction through, but not the other direction. And that's the basis of polarimetry. So the SPHERE instrument, it does that. It also blocks off the parent star, so you can see the details of things around it. And it's got an adaptive optics system. So it's capable of very high resolution imaging things involving dust. It works in the infrared. I can't remember whether I said that, but it's an infrared instrument. So you're looking at the heat that these dust grains are radiating. And so with SPHERE, they've produced this new image of the dusty disk around AB Aurigui, and revealed a detail that's got everybody very excited. Because looking at this dusty disk, I don't know about you, Andrew, you're probably looking at the same image that I am, and it's pretty easy to find on the web. But it looks like a spiral galaxy. It's got that spiral structure to it, which we're familiar with in gigantic spiral galaxies, which, of course, are gazillions of times bigger than this. But what's interesting when you probe deep into the spiral structure, not very far from the star itself, there's a kind of kink in it, a little twist, where the spiral structure changes direction. And that is being highlighted as where a planet is actually in the process of forming. Because what you're seeing is two columns of material basically accreting onto this planet, which itself will be rotating. And it's a really beautiful image. The planet being formed is about as far from its parent star as Neptune is from the sun. So it's a kind of outer solar system type thing. But to see it with this kink in the spiral structure and realize that that's where a planet's being born, it's one of these things that, raises the hairs on the back of your neck. It's quite exciting.
Yeah. Do we know what kind of planet it might turn into? Is it too early to say?
I think it is too early to say, but if there's any, if you can take any lessons from our solar system, it probably will be a gas giant or an ice giant, looking at Neptune as a role model for that. Neptune may have a rocky core. We don't know. This planet may have too. We know even less about that. But it's very exciting to see, planet formation in action. And the thing that I guess makes it doubly significant is that when theoretical astronomers build models of the way planets form in dust disks, these kinks are exactly what you would expect to see where a planet is actually in the process of formation. So they were predicted, and now they've been seen.
Yes, and another sort of stupid question from the peanut gallery. How long would a process like this take?
Yeah, that's not a stupid question at all. I think the media have got hold of this and said the instant of planet birth. That instant probably is going to take
that sounds about right.
10 million years or something like that. So it's a long. How long? I would guess it will be measured in millions of years. It's maybe not too many, because there's sort of growing evidence that planet formation is a relatively quick process. We used to think it took hundreds of millions of years, but I think it's more likely to be millions or tens of millions of years.
So this one's really in the early stages. This is probably just sort of beginning.
There's not really anything to see. I mean, the problem is that at 520 light years away, the planet itself is well below the resolution threshold, even of an instrument like SPHERE. But the all the evidence is there. This kink in the spiral structure, or the twist, as they call it.
Very good. By the way, Fred, SPHERE, Spectropolarimetric High Contrast Exoplanet Research.
There you are.
That's the name of the instrument. That's attached to the
VLT. I knew you'd have it on the tip of your tongue. Thanks very much.
Yes. Oh, no. As soon as you said you didn't know what it meant, I had to look it up. Because I knew it was going to be some impressive combination, and it certainly was.
Yeah. So as you can tell from that, it was designed to look at exoplanets, at planets in orbit around stars much nearer than AB Aurigui. But it is actually it's a versatile instrument. You can use it for all kinds of things, including the dusty disks of young stars.
Okay. All right. Well, clearly we're going to have to wait for the next stage of this discovery. We might have to wait some couple of million years or so, but we'll let you know.
I think it's interesting. Just on that point, Andrew. so this is at the distance of Neptune from the sun. So it's going to be orbiting in a couple of hundred years or so, once every 200 years. So it's certainly possible that if these same astronomers use the same instrument to look at this object in a decade, they might see a difference in the shape, in the structure. There might be a difference that's discernible. We should ask them to do that. They'd probably do it for us.
Yeah, they would indeed. So it's a watch this space boom boom scenario.
Yeah,
there it is. You're listening to the Space Nuts podcast. It's episode 204. Andrew Dunkley here with Fred Watson.
Roger, you're loud and clear here also.
Space Nuts.
Once again, a big shout out and hello to all our social media followers, whatever platform you may be on, YouTube with our 1.25 thousand subscribers. We've got people on the Space Nuts podcast group on Facebook. And of course, we have an official Space Nuts Facebook page. But we also, I also communicate through a whole series of other astronomy Facebook pages and social media platforms. And we quite often get comments there as well. So hello to you. And thank you for listening to the Space Nuts podcast. And thank you for sending in your questions. We've got a couple of new questions to deal with today, Fred. And we have an audio question today from Wellington, New Zealand, from Giuliano.
Hi, Andrew and Fred. My name is Giuliano. I live in Wellington, New Zealand. My question is about extraterrestrial intelligence, or rather, about our own intelligence as seen by an alien race. I've often heard people say that any race that's able to reach Earth will be so superior to us that to them would look like ants, octopi, or chimps look to us. Do you think aliens may apply a sort of cosmical baseline to define intelligence? Like, for example, the capacity for self-awareness, reasoning, problem-solving, or dramatically altered environment. I'm a long-time listener. I've also just read The Terranian Enigma. Good work, Andrew. I'm yet to summon the courage to read one of Fred's books, but I'm sure I'll get there eventually. Thank you so much. Bye.
And Giuliano, it does require a lot of courage to read one of Fred's books. I will say that. No, of course not. They're fabulous. I've got a couple of yours, Fred. I'm looking at one right now. Start Craving Mad. And why is Uranus upside down? I like that one. Yes. Oh, and Giuliano, thank you for reading the Terranian Enigma. The feedback has been very, very positive. People are enjoying the story and the twists in the story. And so far, nobody has come to me and said, I picked it. I picked it on page 42. Actually, someone did say that, but then they were wrong. But yes, I appreciate it. Now, Giuliano's question fascinates me because I love talking about extraterrestrial life. And as I mentioned earlier, we did discuss through another question how humanity might react if we suddenly tomorrow learned that there was extraterrestrial intelligent life. But Giuliano's question sort of flips the coin. What if they found us first? And how might they perceive us? That is a really interesting question to discuss and debate, I imagine. I think so.
Absolutely, it is. Exactly as Giuliano says, and he asks exactly the right question: how do you define intelligence? And it's not an easy thing to define. I think it was, if I remember rightly, Carl Sagan who offered the definition that an intelligent species is one that is functionally similar to ourselves. In other words, that they, they have the same sort of reasoning capacity as we do. But that is only seeing half the story, really, because yes, that's our perspective of what it might mean. But if you put yourself in the position of another intelligent species, and I guess if they're going to be aware of our presence, they would need to be at least as intelligent as ourselves or more intelligent, because they would have to have the technology in order to in order to detect that there were other intelligent species in the universe. So that suggests that, yes, any intelligent species that found us would be more intelligent than we are, or perhaps the same. But would they, how would they...
Or just unlucky.
Oh, just unlucky, yeah. Would they regard us as, well, these are interesting things. They've got all kinds of behavioural problems that we don't have. I don't know. It's I think, as Giuliano says, they might define intelligence as including the capacity for self-awareness, reasoning, problem-solving, and altering the environment, of course, which is another definition that's been made of what a living organism is. But it is hard to put yourself in their place. I guess the nearest thing that comes to mind on this, and I always come back to this old chestnut. My favourite science fiction movie being 2001: A Space Odyssey. At the end of that, what you see is a benign intelligence. Well, in fact, all the way through, the message is a benign intelligence trying to push these earthly creatures in the right direction, and eventually turning them into nothing but energy, I think, is more or less what happens at the end of it. Maybe that would be an intelligence that likes the idea of bringing along other less intelligent species, but whether all intelligence will be like that is another question altogether. Certainly, Stephen Hawking didn't think they would be. He thought they might eat us for breakfast.
Yeah, I think Giuliano's question was actually demonstrated in one of L. Ron Hubbard's book when an alien species came to Earth, and they didn't look at humans as anything but an animal that lived on the planet that had no other level of intelligence than any other animal on the planet. I'm just trying to think of the name of the book. And they made it into a movie which starred John Travolta, and it was, I think, designated the worst movie ever made. But it demonstrates the exact question that Giuliano raises, that these aliens turned up and did not see us as anything but a passing interest. And somewhere along the line, they discovered that we actually were intelligent. But it's a fascinating question. And I suppose it also brings into play the question of the likelihood of extraterrestrial intelligence. And you and I both agree that in the not too distant future, we will probably find microbial life of some kind, probably within our solar system. And there are 2 or 3 prime candidates for that, which we talked about recently. But it is a giant leap to reach a point of intelligent life. And we on this planet, being the only example of it anywhere in the universe that we're aware of at the moment, are probably, or perhaps, let's say perhaps, a freak of nature.
That's right, but actually, it's not just
notwithstanding the biblical angle. I'm not dismissing that.
There, no, that's right. But it seems that the step from single-celled organism to multi-celled organisms is the one that's the really difficult one to make. And maybe once you've got things evolving, when you've passed that hurdle, then they may well evolve fairly quickly. Because, of course, intelligence is a spectrum. We are at one end of it, but we're not that far in front of dolphins and the chimpanzees and other creatures who've certainly got a level of intelligence. There was a comment made, I think this is Charlie Lineweaver who made that, who suggested that the process of reaching the level of intelligence that we have reached is not an inevitable one in itself, because what it points to is the fact that 130 million years ago or so, that's when the African and South American continents, separated as Gondwana broke up. I think it was about 130 million years ago, if I remember rightly. And the ingredients of what became Homo sapiens were there in both halves of this. It broke up, but it was only in Africa that we saw the emergence of the early hominids and eventually Homo sapiens. So his point is that it's absolutely not there isn't a predetermined pathway where you've got all the right ingredients, you will get progressively more and more intelligence. He's suggesting that even the development of intelligence and a big brain is almost accidental. So yeah, it's that's stuff we can talk about for hours. But
oh yes, I mean you've already prompted another thought in my mind, and that is, okay, we are Homo sapiens, and we sort of took over the planet, but we weren't the only humanoids to occupy the planet, and for a time we coexisted with other species, and it could have gone either way. I mean, there's talk, there have been suggestions through anthropology that Neanderthals could have become the dominant species, except we, I think the story goes, were more intelligent, or at least more versatile, and managed to survive where they failed. And there's even another argument that we bumped them off.
Yeah,
and so that's how we became the dominant intelligent species on the planet. But I like watching a lot of nature documentaries, and you see intelligence in creatures that have social organisation. I'm watching a series about saving orangutans. There's been a wonderful series that I've watched on subscriber television about the orangutan jungle school over in Borneo. And when you watch these creatures and you get to know them, and you do actually, through watching the show, get to know individuals, you see personalities, you see intelligence, you see problem solving. Intelligence, for a long time we thought that was us, but it exists in so many creatures. It's just a different kind of intelligence.
Yeah, that's right. So
for Giuliano to suggest that aliens coming here and finding us, or at least observing us and understanding us, may see us as chimpanzees, I think is a fair argument.
Yeah. It's great stuff.
It is, I know. It just you can go on and on and on about it. I love it.
Before, I think it's about the movie that you said was the worst movie.
Oh, it was Battlefield Earth.
Oh, okay.
Battlefield Earth. Yeah. I think that's the one.
It reminded me of a story I once read, once again along these lines, in which the aliens came to Earth. And they found all these creatures with a hard shell, which they thought were the intelligent creatures. We would call them cars, but they thought that the things in the cars were just parasites that on the back of or on the inside.
Oh dear!
So yeah, interesting stuff. How do you measure intelligence?
One of my golf partners who loves science fiction has recently watched a series which I haven't watched yet, or it might have been a movie, where all the intelligent people, the highly intelligent people of the world, die off. And suddenly the most average man in the world becomes the most intelligent man in the world. It's all sort of, and everyone else is dumb. So I can't wait to watch it. That sounds like fun. I'm pretty sure it's a comedy. But Giuliano, thanks so much for your question. Really appreciate it. Nice to hear from you, quite literally in that respect. Let's move on to our last question for this week from our good friend Ulf Peterson in Sweden. I think last time we answered a question from Ulf, I was able to give him the wonderful news that a young Swedish lass won the New South Wales Women's Golf Open here in Dubbo, which I'm sure he was pleased to hear. Well, he writes, "Hello again, Andrew and Fred. Summertime is approaching rapidly here in Sweden." This goes on a bit, but it's worth reading. Summertime is approaching rapidly here in Sweden. Since we all are all still stuck in the middle of this COVID situation, there are only two activities that prove meaningful. One, exercising proper social distancing out on the golf course. Yes, we are still allowed that. So are we, Alf. And two, brooding over astronomical conundrums. The first type of activity is now made extra fruitful thanks to a funny little book called 5 Irons Don't Float. It's in my bag for summer. Great stuff. That's a book I wrote, Fred, about golf psychology.
Yeah.
Yeah. I'm so pleased that Alf's got it. I want him to tell me what he thinks. And I should warn you, if you haven't read it yet, Alf, it has coarse language in it. And I'm talking both kinds. Anyway, the first type of activity is now made extra fruitful due to the book called Five Irons Don't Float. The second activity, which I stress should not be performed at the same time as the first one, provides a good workout for the little grey ones. Because I have already found help for the first activity, it is about the second one with which I wish to ask a question. First of all, he starts with facts. The Hubble constant is a measure of the rate of expansion of the universe. A strong scientific evidence is said to be the redshift of light passing through space towards us on Earth. But to finalise this model in its entirety, we need to detect both dark matter and dark energy. However, our failure here is still a conundrum. So the question is there really no other way of explaining the redshifting of light, or even to detect a slowing down of the speed of light through space over great distances as an alternative explanation? If we peek out at the universe from Earth through a window of, say, 1 degree, we notice few objects close by, but at greater distances, we find an increasing number and sizes of objects. In fact, looking toward the edge of the known universe, we should, in principle, detect an unlimited amount of mass due to all the objects. Is there no chance that this immense mass, albeit over vast distances, could not account for any overlooked effect on what we call the Hubble constant? Cheers for me for not stumbling on one word. Thank you, Alf. Good question.
That was great.
And thanks for buying the book.
Yeah. Yeah, so it must be some good physics in Five Irons Don't Float. It
was inspired by Rory McIlroy after he played a bad shot and threw his 2-iron in a lake.
Okay.
And it just said, because he had a tanty, and I decided I'd write a book about it. So that's what happened. But I chose a 5-iron because no one carries 2 irons these days.
Right. So that's
which is probably why I threw it in the lake.
Might be. That might be why. So, okay. So to Ulf's comments and questions, there's a caveat that I would put in what Ulf describes as the facts. Yes, the Hubble constant's the current rate of expansion of the universe. Let's put the details on it. And he says to finalise this model in its entirety, we need to detect both dark matter and dark energy. But we have done that. We know they're there because of the properties that we see the universe exhibiting. The problem is not detecting them, is working out what they are. And yes, that is still a failure. I'm hopeful that dark matter might actually yield its secrets to us not too far down the track. There's a lot of hopeful and promising signs. But with dark energy, we're still really at a loss to account for this, at least at the subatomic level, as to what's going on. But Ulf, your question, is there really no other way of explaining the redshift of light other than the expansion of the universe, or even to detect a slowing down of the speed of light through space over great distances as an alternative explanation? The thing is that a lot of people have looked at this. I remember back in the 1970s, it probably was, there were people who were looking at alternative explanations for redshift. And one of the things that led to that was a scientist I actually worked with in the Royal Observatory in Edinburgh, thought that he had detected what you might call a quantization of redshift. In other words, the redshifts were sort of clustered around particular values that would suggest that there was something going on that we weren't aware of. In fact, that when you look in more detail and with better instruments than we had in the 1970s, you could see this effect disappearing. So there is no, there's no quantization. There are clusterings of redshift, but we understand why that is. It's because of clusters of galaxies. Tired light was another suggestion. People have looked at this, tried to demolish what you might call the standard picture for a very long time. And the reason why the standard picture has held its ground is because when you look at the universe as a whole, and we now have the wherewithal to look back almost to the first galaxies being born, we can certainly see the flash of the Big Bang, the cosmic microwave background radiation. We can see the ripples in that, the tiny temperature differences that are the effect of sound waves, kind of echoing through the Big Bang. All of that gives a really strong self-consistency. It all works, and usually when you throw in another suggestion as to what might be going on, it throws something else out, and nothing makes sense. That's one reason why one of the early proponents of an explanation for the phenomenon that we now refer to as dark matter, the idea that galaxies are spinning too fast to hold themselves together, that clusters of galaxies are moving too fast. There's too much circulation within the cluster for the cluster to hold itself together. Those are what we observe. We now observe much more than that, but back in the 70s and 80s, there was this suggestion that maybe we've got gravity wrong, that Newtonian dynamics are different, and that led to a theory called MOND, Modified Newtonian Dynamics. A man called Mordechai Milgram, I think at the Weizmann Institute in Israel, did that work. And so what it means is that we modify the idea of how dynamics work, and you can get rid of the puzzle with galaxies spinning too fast, but it doesn't do much for the problem of clusters of galaxies. And it turns out that you still need dark matter. It just doesn't work. You've got all these inconsistencies over the bigger picture. So it's really the self-consistency of our view that leads us to accepting the current conundrums. And the idea of looking at a 1 degree window, it's a great idea. You look further and further out, you see more and more objects. That is something called Olbers paradox, which cropped up in the early 19th century, late 18th and 19th century. Olbers paradox says that if the universe is infinite, you should see a dazzlingly bright sky, because on any line of sight, you're always going to find a star on it. He talked about stars at that time. And of course, we don't. We see darkness. And that is because the universe is expanding. It's because we see the light of things being redshifted. So our skies are dark. They're not infinitely bright. There is an immense mass in the universe that actually feeds into all the calculations that go to our sort of self-consistent picture. I think any overlooked effect on what we call the Hubble constant, as Ulf mentions, I think that would have been found already. There are a few mavericks from time to time. I actually worked for one for a while who had a quite kind of different picture of the way our galaxy works. But overall, what you're looking at is the consensus. The consensus was, in that case, was that galaxies are as we understand them. And so the effect all went away that my maverick colleague was looking at. As I said, there are mavericks, but generally speaking, what we take is the overall consensus. And that leads us to dark matter and dark energy, for better or worse. Science is science, though. And if something does disprove that, then it will be taken on board. Our picture changes. We define things differently as we get to understand them better. So you could almost say, as always, watch this space. There may be changes, but I think what's more likely to happen is we'll figure out what dark matter is. It'll be some species of subatomic particle or family of species of subatomic particles that have eluded us so far. And hopefully one day we'll find out what dark energy is as well.
Oh, yeah, indeed. That would be one of the great moments, and we hope that will happen in the not too distant future. But who can tell? It's just one of those great mysteries that people are working on, and fingers crossed that they will make the connection there sometime in the not too distant future. And Ulf, in terms of your two questions, stick to golf. Oh, and one little tip from my book: it's not about not hitting it in the water; it's about not thinking about hitting it in the water. That's the way your brain should work on a golf course. Mm-hmm. So, and thank you for the question. Really appreciate it. And Fred, I think that winds us up for another week. Thank you so much, sir.
It does. I'm very glad to have spoken with you again, and I look forward to the next time, Andrew.
It'll be in about a week or so, I imagine. Take care, Fred. Thank you.
Yeah, no worries. See you soon.
That's Fred Watson, Astronomer-at-Large, part of the team here at Space Nuts. And thank you too for listening. Thank you for the questions. Don't forget, if you want to send an audio question, go to bytes.com/spacenuts, and there's a little recorder button there. As long as you've got a decent microphone built into or plugged into your device, you can simply record the question. Don't forget to tell us who you are. We really need to know that. Your name and your location. You don't have to tell us your entire name and address and tax number or anything like that. Just your first name and your location would be more than ample, just so we can sort of connect you with the question. And we look forward to what you're going to come up with in the near future. Of course, we're still taking questions on email, etc. So don't feel that this is the only way. And while you're on our website, have a look at the Space Nuts shop. There's all sorts of goodies there. There's also information about how you can become a patron. So it's bytes.com, bitesz.com/space nuts. From me, Andrew Dunkley, thanks again. Catch you again next time on another edition of the Space Nuts Podcast.
Space Nuts. You've been listening to the Space Nuts Podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.